Assalamualaikum warahmatullahi wabarakatuh. My name is Hazmi Hazlan and today I'm going to present my FYP project entitled Time Frequency Distribution Analysis of EEG, or known as Electroencephalogram, during maintained alamatic task performance. So I will start my presentation with my motivation, or as my introduction. So cognitive is a term that refers to a mental action process of acquiring knowledge and understanding through thoughts, experience and sense. While 10 taking this ability, such as attention problem solving, for granted, cognitive disruption can occur and create a havoc in multiple areas of individual life. So these are the example of multiple effect related to cognitive problem, which is such as Alzheimer's disease or memory loss, brain trauma, cognitive therapy or physical illness, and so on. And this is in graph 1 showing the number of deaths due to Alzheimer's disease in different states in the world in 2018. And also you can see that California have the highest number of deaths due to the Alzheimer's disease, and this can relate that the cognition is very important for our future and for our happiness and for our health. Okay, now I will explain my problem statement. So in problem statement, I will state 3 different problem statements, which are: the first one is the group of arithmetic tasks is different in patterns based on the EEG signals. Second, time domain and frequency domain based techniques are not suitable for the groups of arithmetic tasks in classification. Lastly is the different types of data reduce the quality of the classifier. So it requires the search for the most accurate classifier for the electroencephalogram signal. Next is on my objective and scope. So I have also 3 objectives, that is to analyze the signals EEG during mental arithmetic task performance by using time frequency distribution. And second is to classify the groups in arithmetic task performance based on the EEG signals in TDF features. Lastly is to compare the different performance of classifiers such as KNN, K nearest neighbor, support vector machine and other in terms of accuracy and efficiency. So the scope of this report is limited to observe the groups of mental arithmetic task performance in time frequency distribution and classify the signals of the subject by using EEG signals of the VRMS. So this is my literature review. My literature review starting from cognition, response, EEG, features extraction containing time domain, time frequency domain and frequency domain. And lastly, the signal classification. So cognition response, as I said before, it is referred to a mental action or process acquiring knowledge, understanding through thoughts, experience and sense. Next is EEG. EEG is actually an electrophysiological checking technique to record the electrical action of the mind or of the brain. It is non-intensive, which means that it is not harmful for human because although there are terminals and electrodes set along the scalp of the brain, and the electrical impulse of the EEG recording looks like wavy line with peaks and valley. Based on the recent study of EEG signals, they use neurocore monopolar EEG 23 channel system from Ukraine. So based on figure 1 showing the device of the neurocore monopolar EEG 23 channels, and the electrodes are arranged according to the position of left, right and center. Next is feature extraction. The aim of feature extraction is to reduce the number of features in the dataset into a more manageable categories or process. What are the features that can be used in EEG signals? They are classified into 3 categories, which are time domain, frequency domain and time frequency domain. Here are the example of the graph of frequency domain, time domain and the time frequency domain. Next, we will continue about the advantage and disadvantage of features. The first feature is time domain. It is simple and efficient in EEG pattern recognition, but it have a non-stationary properties of EEG signals. Secondly is frequency domain. It can estimate the EEG power spectrum, but it have a high environment noise. Lastly is the time frequency domain. The advantage, it can overcome the limitation of time domain and the frequency domain, but it have a high dimensionality because it consists of 3 vectors, which is X, Y and Z. Okay, next we will continue to our signal classification. So signal classification is to plan, recognize and estimate the various example of data gathered in EEG signals, and by providing a preparation of a set efficiently, we can estimate the information into the classifier, and then the classifier will give us the regulated information in terms of accuracy and so on. Okay, next, based on table 3 showing the advantage and disadvantage of different types of classifier. For the first classifier, that is SVM, it works very well when there are clear margin of separation between class, but it does not perform well when the dataset has more noise. Next is KNN. It is very simple implementation, but it is a lazy learner. while in assemble it can work well with noise, but it cannot be considered as a consistent and accurate classifier for real world use. Next, I will continue to my methodology. So in my methodology consists of 3 stages, which is signal pre-processing, signal processing, and signal classification. And this is my overview of my methodology, starting collecting data and import it into the MATLAB, separating the 23 signal based on one subject into 19 signal, and then using features extraction of time frequency distribution to gain the average of VRMS of the subject signal. And then we continue to the signal classification, which we separate the data of train, then we import the training data into the classifier, continue with comparing the result based on different classifier and determine the accuracy of the data, which one is better than other, which one is better. Next, we will continue to our result. So the first thing in result, I will talk about the data set of EEG signal. Based on recent study, the data was collected to investigate the EEG signal mental based on the arithmetic task. So the arithmetic task in this study involved the serial subtraction of 2 numbers as shown in figure 2, which is, for an example, 4-digit integer, that is 4753 is minus with 17, that is equals to 4736. That is the example of arithmetic task. So the participants are set into a dark soundproof chamber and sit in an armchair. The first 3 minutes are spent explaining arithmetic task, followed by the 4th minute spending doing the arithmetic task. In figure 3 shows the progression of previous study. So based on the EEG signals, based on the figure that is shown in figure 3, showing the time, which is at 3 until 6 and 6 until 7, which is 3 and 1 correspondingly. Next, based on the number of arithmetic operation per minute, they divided the sample of 36 subjects into 2 groups. The first group is group B, containing the difficult arithmetic task, and the second group is group G, without difficult of arithmetic task. In this study, time subject has been used from this data set to continue implementing the time frequency domain analysis to the EEG signal. In table 1 shows the data about the participant subject and it is summarized. So F is marked for females, M is marked for males, and count quality is based on the difficulty of the task, which is B and G, with difficulty and without difficulty. Okay, we continue for the first stage, that is signal pre-processing. The signal is then separated from 23 signals into 19 signals, and the remaining signals are not included because the information or data contained are the same. There will be no filtering frequency process, because due to the properties of numerical monopolar EEG 23 channel system, which can remove all the artifact or noise inside the signal of EEG. Okay, the EEG signal data was run using the MATLAB software, and the graph of the EEG signal is a voltage versus time, and it shows as the amplitude of EEG signal during the test. In figure 4 shows the raw signal in EEG of the single subject consists of 23 electrode, while in figure 5 show the separated signal of electrode, which is FP1. Okay, we continue to the second stage, which is the signal processing. We continue by extracting the parameters of the EEG signal, which is the RMS voltage, and then based on figure 6 shows the RMS or non-VRMS that has been extracted from the single signal electrode in FP1. The mental state is difficult to describe or recognize since the EEG signal is not stationary, and features extraction is particularly important because it is as a step in the classifier process. Okay, we continue with the third stage, which is signal classification. The project last phase is to find the appropriate classifier for data EEG signals from different groups. So, the techniques are often used to prevent confusion with several classification decisions and to improve the classifier efficiency by eliminating classification error. Here are the classifier analysis, which is in table 5, showing the 100% data that is being trained and import to the MATLAB to gain the percentage of accuracy based on different classifier. While in table 6 showing 80% and 20%, which is 80% training and 20% testing. And we gain based on the different classifier that KNN have 100% in training and 100% in testing. Okay, now I will continue with the demonstration. How do I gain the result? Okay, now we will continue for the demonstration. The first stage is signal pre-processing, where we separate the signals from the single subject consists of 23 signals into 19 signals. So by using MATLAB, firstly we have to open the file that contains the EDF format, and I will first show the info of the subject. In this info we can see the file name, we can see the file size, we can see the duration, and so on. And then after that we will read the data. Okay, based on this data consists of 23 different signals of electrolyte, and based on the single column are the data. So we have to separate the data to gain a single data to continue for the features extraction. So okay, and then we gain the data which is as shown like this. So here are the example of the raw data signals of the FP1 signal. Okay, next we will continue to signal processing, but the features being extracted is TFD, time frequency domain, based on the EEG signal, which is the RMS voltage. By using also the MATLAB, we open the file that is related, and we use 10 subject, that is from subject 0 until subject 9, that consists of 2 different data, which is before and after the arithmetic task. So we will open the before arithmetic task and we will show the example for the FP1. So this is the coding to gain the features extraction of time frequency domain and to gain the VRMS. And first we have to read the data. So here is the data, and then after that we run. So in this graph shows the RMS voltage, and we will take the data of average VRMS, which is this one, 1.9031 to the power of 10 minus 5. We will copy the data and we will put it into the data collection based on the average of VRMS. Okay, next, the last phase is the signal classification, where technique classifier are used to the signal classification to determine the best machine learning for EEG signals after collecting the average of VRMS data of the EEG signals. So by using the MATLAB, we will open the apps and we will open the classifier learner. And then we will open the file that consists the 80% of the data to be the trainee for the data. So the data is separated between the classes, and we will put the selection, and then we tick the no violation. For example purpose, we will use find KNN as our classification, and we open the confusion matrix first, and then we train the data. So the accuracy by using a KNN classifier, we gain the accuracy 100%. And as you can see in the confusion matrix, based on the true positive rates, it shows that the bad and good group have 100% of true positive rates. This means that the data that is imported to the find KNN classifier is good, because the prediction based on the true class and the prediction class is mostly like accurate. That's all for me. Thank you very much. For the last part is the conclusion and recommendation for the future work. So as a conclusion, the purpose of this study is to use time frequency distribution to analyze the surface of EEG signals in VRMS based on arithmetic task performance. And in addition, using EEG at TFD, we can classify the accuracy based on the categories of the group of the level of arithmetic task performance. There are 3 classifiers that we use in this project, which is SVM, KNN, and Assemble. So based on the table 7, we can see that 80% and 20%, which I said before, that is training and testing, we gain KNN have the higher accuracy, which gaining 100% of training and 100% of testing. Next is recommendation. For this project can be used in future purpose by conducting additional research based on brain related activities, and its purpose is to collect information for the category based on the difficulty arithmetic task performance, and to ensure that the classifier accuracy is accurate when it comes to brain activities. Thank you very much. My name is Hazmi Hazlan. You can turn on the notification bell, and thumbs up.